This conference will now be recorded.
All right, now let me attempt to share the screen. All right, hope that's coming through well. All right, is that big enough? Everyone can see that?
Yeah, it's good.
Works for me.
Perfect. All right. So we had 5 open questions, I believe. Make sure it's still 5 or 6. And then the request today, I believe, was to go through the SM bus requirements and PCI Express resets. So let's scroll down. Let's connector, ref clock, PCI Express reset. Because kind of in the survey, these are where we got some responses that were, not necessarily fully aligned. So, Mohammed, do you have a preference which one you want to do first, reset or SM bus?
Well, maybe this one is a less controversial, is the PE reset or the PERST. I just want to make sure that people are making sure, that if they're saying that is no opinion, they're relying on the spec. The spec does not make it mandatory. At least that's the last time I checked with our PCI expert. If the team is saying yes, 38.5%, then I'd like to hear why. And if it's mainly for resetting a drive, is there another way we can do that? Or, I think we're insisting on that as the number one choice.
Mohammed, maybe one other nuance here, and I think maybe our question. So, this wasn't just PCI reset, it was per port. Should we tease those apart separately, maybe?
I think, yeah, let's start with, is it necessary if you have a single port, regardless, right?
Well, isn't it required?
That's what I,
if you have if you have a PCIe endpoint, I think you have to have PERST.
That was my understanding until I talked to our local expert, and they said, no, the spec does not make it a shull. It's if you get a controller that can wake up and has the necessary power levels, etc., it does not really need PE reset to deassert. If PE reset is always deasserted, it will come up as soon as it can. The reset functionality that was not made, Alvin Cox at least, that was the note that I got from him. He's our rep on the PCI SIG. It was not deemed as a shall have a PE reset.
Yeah, I think that is right, Mohammed. And maybe, I don't know if Larry or someone else can echo, but I mean, on power on, the endpoint will go through some kind of protocol, but I mean, and it's form factors pick whether they want the sideband or not, but most of them do.
Yeah, historically, I ran into a bug a long time ago with a PCI target that was, upon power off on the server, that target did not get the message and was receiving bad data off of floating data lines. Well, okay, it received bad data, it realized that bad data, but then it got confused and it was a bug in the IP. But hopefully those PCIe target IPs have been fixed since then, and it should not matter if PE reset is not there.
But if we take this concept and think about it from a hard drive perspective, right? So today, if a host is responsive in the ASIC, but something is not right, you can send an in-band reset, which I would call that a warm reset. But if we really want to power cycle the drive and really reset the ASIC inside of it, we tend to have power circuitry that pulls 12 volt and 5 volt. I mean, there's a power disable bit, but not every platform supports that. So I mean, isn't this also similar as a property, simply resetting, like giving a hard reset to a drive?
Yes, it can be done through the protocol. You can actually issue a reset, or you can, if it's not responsive on that port, the PE reset tends to be a way to reset a port. You could also power cycle it if it's a single port device. Sometimes it does not respond to a PE reset if it's completely messed up, and it may require a power cycle. Even in some of the debug routines that I've lived through, you start with trying to communicate through the protocol. If you're not able to, you do sideband communication, and then the last resort is power cycle. So in this case, I think if I'm leading the witness a little bit here, but if we were attempting to reduce the number of lanes as much as we can to reduce cost for the OCP community if they're trying to live without having an 8639 type connector that has pins, the full pins required on 8639. So again, the background purpose behind the question, if first is necessary or not, is to see if we can reduce the pin count. If somebody comes up with a reason where, for the sake of cost savings, we still can't give that up, even if it means saving money, that's what I want to hear. I want to understand why, since it was never mandatory by the spec.
All right, so leading the witness, you're proposing we don't require it. That's what your proposition is.
At least that's my mindset on it. It's just because one less signal to deal with, one less pin to add to the connector, and if we can narrow down our requirements eventually to a subset of pins, that's what we started with in this exercise. We went through all the pins that are on the 8639 in comparison to a SAS connector, in addition to a SAS connector. That's what each of the questions was leading towards. Yes, can we live with that being optional or not, or not required? And if it is optional, if we leave it as optional, that means the drive has to do it.
Leave it as optional means the connector must have it, right? It doesn't necessarily force it. So I think that's the key, right? So if we see that's not required, so we say we don't need it, then it won't be through the pin, and it doesn't matter whether the system or device. But if the connector supports it, it lets us late bind a decision on devices and systems at a later date.
Correct.
Well, the question a little bit misleading, right? Is that PCIe reset per port? Meaning if you have two ports, do you need two different pins?
That's how it's defined today in the 8639. You can reset each port independently. And it happens to be that the PE reset for port 1 and all the ports that are above that are available only on the 8639 version of the connector, on the other side of the row. If you remember the 8639, you have two sides of the pins, rows of pins, or the column of pins.
But does that mean that if you had it on one port, that it is not allowed to affect the operations on the alternate port if they're in the middle of it? So that impacts the design of the device to have that isolation.
Yeah, by definition, the PE reset on port 0 should not be port 1, especially for dual port, right? So if you don't implement it on each port, it's might as well not implement it at all.
Well, yeah. I think we should implement it, but sharing all the port with the same pin, reset to go all the ports. The reason I say that because from the system point of view, usually we assert the PE reset during the AC cycle, right? It's a hard reset. during the IC cycle. And when we do that, the reset go out to every device at the same time, right? So if that's the only case happen, doesn't matter you try individual or you sharing, all the ports should see the PE reset at the same time.
In a single port architecture, I fully agree with you. In a dual port architecture, those first signals are carefully isolated so that if you have a redundant system and you want to continue to access that device from one host and the other host, for example, is no longer able to access the port A of the drive and you still have access to port B, you never want to hit a single reset that resets both ports. That way that drive goes away. So that's, I think Brad Besmer was on a discussion where he said it's must have for a lot of the enterprise guys to have the isolated resets. And I respect that and I understand that. But again, this is an OCP spec. So if we want to create an OCP spec that has additional cost association with a dual port version that we don't need, that's where I'm struggling with that.
You also have to look at the probability on the failure mode. So you have to have a failure mode that the protocol reset doesn't work on one port, and the probability that the other port is still going to be running if the protocol's reset didn't fix the first port. So it's not a systemic problem in the device. It's a localized problem in the port circuitry. I don't know what the probability of that failure mode is, but that's really the only failure mode where you need that isolated port reset.
Yeah. So putting the OCP hat and knowing that mostly OCP members care about a single ported device.
So Mohammed, I need to stop you. This is not, do you need dual port or not? This is, do you need PCI reset per port? Do you need PERST or not? That's really the question. The per port is just distracting this, right? Yeah, it's really the other question of dual port versus single port is the answer for dual. This should not be answering, do you need single or dual port?
Okay, so let's just go back then to it. Let's assume it's a single port, right? And the first question, do we need PERST for a single port?
I have a fear of 99.9999% of the implementations today have PERST.
Yes.
And I would say nobody has done interoperability testing at all except for isolated systems without PERST.
And does PERST typically go in and cause a power on reset to the device?
No.
Or does it go as
no. It synchronizes the protocol when the device comes back up. It's
part of link initialization.
So it goes in as an interrupt to the processor.
Yep.
Okay.
And it's also interrelated with common clock. If you're doing ref clock, then PERST has timings for when client clock is stable, then PERST goes away after the clock is stable. So there are some intertwinings there too.
Right, and they're different for different form factors. Well, there's some consistency, but some of the form factor specs tend to specify how they want PERST to work.
In U.2, PERST is not an optional signal; it's required. If you have 2 ports, it's required on each port. There's a PERST and a PERST B.
Maybe by the U.2 spec, but not by the PCI spec. Yeah.
I'm talking about the PCI spec, the SFF 8639 module spec, PCI SIG.
Yeah, but
Mohammed's talking about PCI itself, not because this will be a new form factor by itself anyway, right?
Yeah, it is true. I'm looking at the base spec now, and the base spec allows for endpoints that do not have the sideband, and it says essentially that if the sideband signal, if PERST is not there, then the mechanism, an endpoint can autonomously reset itself, and the details of all that is outside the scope of the spec. So from I agree with Brad. I think the entire ecosystem, or 99% of it, of the PCIe ecosystem uses burst, and I would be certainly scared of not having it for an HDD. But
can I make a proposal? I think so let me see if I can understand the intent. So I believe Mohammed and Tim, their goal is to see, is there any way to reduce this so that it uses a lower cost connector? So fitting in a SAS connector. That's kind of what they were proposing in the last couple meetings. But if that's at risk of breaking a lot of the norms that people are expecting, especially from a protocol compliance, if we simply looked at using, call an 8639 connector, removing all the extra pins, so we're basically having the same plastic shell, a SAS, right, with a few extra pins loaded, you're into maybe 10 cents and a connector cost in addition, without risking kind of the deployment and the adoption of this, if PCI reset ends up being required. So are we over optimizing to save a few cents in the connector? I mean, I think the key is we have to look at, not a full 8639 connector, but what is the cost adder of using that plastic shell with just a few extra pins compared to the 29 pin SAS, right? And if that ends up being fairly small, this is maybe where we can have Tyco, Molex, Amphenol kind of give us a delta. Obviously everyone pays different costs for connectors, but perhaps they can show like SAS connector is X, 8639 is 2X, a proposal to use 8639 with depopped pins is 1.1X. So if it ends up being like 10 cents, do we think we're trying to over optimize here?
Yep, I think that's basically the question, and it ties back to the next question, which is out of band management and SM bus support mandatory, because those are the remaining two that we feel like are the hurdle between being okay with a SAS connector or not okay, and we have to create this customized new connector.
So you got to think of it from, okay, let's just say 8639 is the system side, but on the drive side you wanted to use a SATA connector because that's compatible, right? But there's no pins left for PCI signals. So that's part of this reason, is getting rid of these, quote, extraneous PCI signals that are not capable of using a SATA connector because there's just no pins left.
Right.
But is that a problem? So, I mean, the way I see it, whether it's the 8639 or the drive side connector, I mean, there's a fixed cost for the plastic shell, and you basically have a cost per pin. So obviously you want to reduce the cost on both sides. So let's take, whatever, I forget the mating receptacle for 8639 on the drive. If you only have to populate the equivalent of, call it a SAS connector, right, with 4 additional pins, your cost burden isn't all that bad.
So notice I said SATA.
I noticed, yes.
SAS connector has enough pins for these. SATA does not.
Yeah.
Does the SAS have enough, even though we said that they require? Oh, I should take it back.
SAS has enough for one port.
One, got it.
Right.
That's why I had the 2 port in here per port, because that basically was the bottleneck, was the burst for port 1 was the issue that prevents us from going to a SAS connector.
You mean SATA connector?
Well, there's another one. The burst 0 is the one that is not available on the SATA connector. There's no pin for it.
But we can repurpose the 3-volt pins, or have you already assumed you're repurposing those?
We assumed for the SAS version is that you can repurpose the burst 0.
Sorry.
But for SATA, the SATA, we couldn't repurpose another pin there.
Well, and that's part of the, are you going to allow multiple protocols, or is this a custom? Because you try to hook 3.3 volts on one side to burst on the other side, it's just not going to work, right?
No.
You're worried about backward. Because we're talking about plug compatibility, if someone plugs one of these into a legacy SATA-based system, that's actually a good point. That's actually why in the beginning I was proposing we don't use the same connector, or we key it, or we do something here to prevent that.
If we have to, yeah. In this case, if we're using the SAS connector, it does not conflict with anything.
That's not quite true. Some
Well, let
people
me look.
repurpose the pins.
I don't think we repurposed that. It was a no connect. Let me see here.
I can tell you from one of the designs I've done in past companies, we did some interesting things on the system based on what would be connected on the drive.
Okay.
But that was really outside of that was vendor unique stuff, right? So it's not.
Yeah, part of the U.3 premise is that I think, if you use 8639, then you should be able to have SAS, SATA, or NVMe, and that tells me that signal was not overlapping, at least.
Well, so if we just bump up a little bit, I was going up. So when we were asking about connectors and compatibilities, I think there was a lot of interest in using an existing. I think 50% said should, not too many in the must, a bunch of no opinions, and kind of a new variant. So I mean, it seems like there's tolerance for considering other connectors, right? It's should use, but not a must. And this goes back to the slot compatibility. I think we had a combination question up here.
Right.
Yeah, basically, I believe that the overall answer was yes, most of us leaning it doesn't have to be backwards compatible. And I think Paul last time said, yeah, they have different inserts that would go into their systems. So they want a system to take both, but a connector as a whole doesn't necessarily have to be interoperable. And then we had some openings here. So I mean, I think all these questions we're trying to answer all go back to the connector, right?
Yep. Well, the simple answer is to use the 8639 and strip the pins that we don't need, as was the original proposal that Seagate put out. I think that is the simple answer. I think we're trying to see if there's any interest in trimming that further to get to a SAS connector at a minimum. At least my target is to see if we can get down to a SAS connector. If we can't, then we know what the answer is. I think the simplest answer is the 8639 with a depop option. And then you can maintain the burst, you can maintain the SM bus capability if needed. That's another discussion we need to have, because let's close on this one first. So are we saying that since the majority of implementations today do expect a burst support in the interop, we need to support it? Is that what I'm hearing? I think that's what I
that was my 2 cents.
Yeah.
That's
No, I'm agreeing with it. I'm not disagreeing. I wanted to give it a fair chance, a fair fight to see if we can reduce. But if
I don't think anybody's pushing for it, Mohammed. It sounds like.
So Dave, is there really do we have examples of where PERST is used and we know it's really going to adversely affect a device if it's not there? If that would be kind of interesting to understand. At least right now, it's just kind of fear, uncertainty, and doubt versus a host does this and we've seen this, and so this is why we need it.
I don't know, Dave, but I've been in M.2 discussions and other discussions on PCIe interfaces and around burst, and there's been a fair amount of thought put into the reset protocols, and it's the predominant ecosystem way of doing things. So with the volumes that we're talking about here, that an NVMe HDD ought to reach if it really be viable, I don't see that this is a huge issue, but that's my opinion.
If it is a small amount of adder, a cost adder, is one thing. And my concern is, when we talk, you're a drive manufacturer, it's 10 cents per drive across, 50 million drives is quite a bit of money.
Yeah. I don't know. I've done just some personal checking, and I haven't found any instantiations of why it's really needed. But I've not done a thorough check. So
there's a presentation Jim has done. He went internally with our software team and the LSI team, et cetera. And if it's not there, we typically assume that we're allowed to start initialization, and we won't wait for it unless it's holding us down. So if there's a pull up on that, typically we are a go and we start initialization, and they don't see an issue. Again, what we're left with is the need for diagnostics solutions to reset a device after a protocol reset failed, and you do not want to power cycle it. It's a solution that remains. I don't believe anybody's IP will break if we eliminate PE reset, because it's not mandatory for the protocol. And yeah, I see what you're saying, Jason, about 10 cents from a system builder, but again, from a drive guy, my concern is, I think the commitment we're trying to come in with from Seagate was, we're coming in for SATA replacement cost point, and the idea is to come in with an aggressive, if you really want NVMe HDD to be disruptive, it has to be at cost parity with SATA drives, and those 10 cents could prevent us from being there.
Yeah, so I fully agree with the intent. I guess my concern is that if half the people said it's required, but also I'm trying to think of the use case. Like, if for some reason we go down this path, we start getting devices and somehow it turns out it is required, we will be hurting adoption. I guess that's my only concern.
Yeah, it's a very valid point.
Well, according to the base spec, it may not technically be required to have a signal called PE reset, but what is required is that you have some way to do what PE reset does.
Right. Ensure that the clock is stable and the power is stable.
You have to be able to do fundamental reset somehow. And if you're going to do it, if you don't have PE reset, it's not the host that's going to be commanding it. You're going to have to somehow figure out how you're going to do it autonomously. And
right.
How's that going to work?
Well, we're also proposing here that we're not demanding clocks, that we are going clockless. So we have to rely on the PLL on the device, picking up the clock from and ensure that you have a stable clock with SRIS. And so I think that is another piece that will complete that puzzle.
Yeah, I really think this answer depends on the clock answer. If you're going to absolutely say it's SRIS only, then this PERST may be optional. But if clock is required, then I don't think you can make this one optional.
Agreed. I think I think the majority of the answers were leaning towards SRIS, SRNS support. I'm going to argue that a clock stability is the responsibility of the device, because you're sampling it from the data lines. Correct me if I'm wrong, Jason, but I think the majority of answers were that we want to go clockless, right?
I believe that was the case. Where was that? Here we go. These are clocks required. Green was optional on both sides. Let's say required on system was blue. Required on device was red. Required on system and optional on device was yellow. So maybe it's a little more split than I expected. Yeah, it's not quite clear.
Required on system, optional on device. Yeah, I don't understand that if it's required on system. I did not understand that. So system would require a clock driven by.
The only clockless one is green.
Yeah. Optional.
Everything else is required on one side or the other. The other ones all have to have the pins in the connector.
Yeah. So I see the predominant answer is the green, right? So my feel is that I think if we want NVMe to become a true interface replacement to SAS and SATA, it better not need the clock when you're routing 100 drives in the box for HDDs, right? Just my concern is the added system implications of 100 PCIe clocks. A true interface would not require that. So that's why SRS, SRNS exist, and to reduce, spread spectrum, to provide reduced EMI, to not having, a perfect clock at the device, because that's a lot harder to route in the system.
So I think this maybe we can kind of learn from others. I mean, if we look at PCI Express based JBoss, so where there are multiple instantiations, including some at Microsoft, where we have a host with a PCI Express retimer goes out to a PCI Express switch in a different box with a bunch of SSDs. We're already doing some of that. So maybe others who have had experience in how it works, and if it's worked, and any risks. Would that maybe to get a few people queued up for the next meeting, people who have built, SSD-based systems that have done it this way?
You mean without ref clock or?
Without ref clock.
Yeah, okay.
I think devices are being required to support SRS, SRNS. That means if you look at the RFIs out there for devices, they tend to require them to be clockless. And I don't know, I think.
Yeah, and the industry went through a lot of trouble. Had a lot of people pushing on component providers to support SRS, and both with spread and without. And it seems like this might be a good time to really just break over to that. I mean, seems to me because the Fiber Channel have been using this similar implementations for quite some time. So
again, the premise is to achieve a solution that can compete with SATA cost, right? If you're designing a SATA system, you're not going to put in clocks on every PCB, and it's just a concern that if we don't get rid of these things, we're going to end up with a more expensive solution.
It seems like we're all still split on this. How do we drive resolution here?
Let's talk to some more of our developers who have done designs.
So I reached out, so at least at Microsoft I can get Mark Shaw to come in. He's led a couple designs, so maybe we can share a Microsoft perspective on what went well, what didn't go well. Dave, do you have anyone else in mind?
I have a couple people in mind internal that I don't want to,
How about
put them on the recording. I want to. I'll talk to him first. But one other thing I'll say, I may be reversing course here as I think back to the one that I crawled through, because we had a big debate about a first issue in M.2 one time, and when we examined the protocol that had been done for that form factor and for others, we found that the way PERST was used didn't make that much sense, in the sense that the timing protocol that was defined really wasn't, there were dependencies that were made that didn't need to be made, and there were things wrong with it. And then when I talked to some of the OS developers that were writing, the enumeration and drivers, they said, they were just picking, kind of putting their thumbs up in the air and saying, well, we're waiting 200 milliseconds or whatever, and trying the device. So it seemed like in that case, PERST, wasn't really used that intelligently, and it wasn't that germane to a successful reset. So maybe that isn't a lesson, but I'd say let's poll a couple more people.
So maybe as a premise, since we're a little over 50% saying optional, maybe at least saying that we'll start with not wanting it, right? We'll try to remove it, but let's have a couple others come in and share their experience.
Yeah.
Yeah, I think it would make sense if we remove the two, right? If we remove the clock and the PERST and see if somebody can come in and argue for them. That'll be a good step. Now, what remains is SM bus, and that one, personally, I see the benefit of it in terms of small systems and solutions in the server, and people wanting to isolate security domains from, the BMC from the main data path, etc. But at the same time, it's, thinking about a high density solution implementation, people will try to not do that, right? They will try, even if it's available on the drive and the connector, the system implementers don't want a tree of I2C that span to 100 drives. It's just a nightmare with multi-target, multi-host, multi-master. I2C is a nightmare. It's, you can use muxes and fan out and design a solution like that, but it will have more issues than it's worth. And when you're thinking HDD for OCP, you're thinking high density enclosures. At least that's what I'm thinking. We may want to poll those same designers on whether they would add I2C to every drive if it's available, and what would that do to cost, and what would that do to stability?
Isn't that more of a system-driven decision, though? I mean,
yes,
the drive vendors will do it if we're asked to. It's not like we,
Absolutely, but it will gear us towards an 8639 DPOP connector, because those pins are not in the SAS connector.
And today,
well, okay. So to be fair, SAS does not have the equivalent of NVMe MI. And Correct. If you're trying to go into a PCI NVMe infrastructure, they pretty much depend on MI at a system level. You can do it in band, but it's very rare that actually works. So most people are doing I2C to NVMe drives today.
Do NVMe SSDs today in a small boxes, but not a lot of people are doing it to 100. Not a lot of people are creating 100 drive SSD boxes and routing 100 I2C clocks and 100 I2C data lanes. And NVMe MI in band is there for that reason. You also have BDM across the PCI out of band from NVMe, but
I guess I'd ask Jason in his JBOD implementation for NVMe SSDs. Do you need MI access via I2C?
So that's something I need to put a little more thought into. So it's less of just a management side. I mean, there's a lot of things we get out of SAS expanders that we don't get out of PCI Express switches, right? So that's what you're getting at. But what's also happening is, the cloud is becoming more secure. We're trusting devices a lot less. And we're doing a lot more security attestation things. So I need to go back and talk to the team to find out, what level of paranoia do we have? What do we require on our system side? So I'd have to get back to you on that.
We need that pros and cons. We need on this one, I feel like we need a bigger pros and cons list to ensure that we're not missing anything, right? There are some hardware complexity in doing I2C trees of that size. There are some potential solutions that could exist within the switch to be the surrogate accumulator of information for the BMC without the BMC to be on the data path. I think if we can come to a conclusion that there is a way to satisfy the security isolation between BMC and data domain or data path, I think we should look into that, because again, there are cost implications, there are stability implications of having a large number of I2C connections.
Question?
Go ahead.
What's the linkage between I2C, I3C, and VAUX? We have that question that's just above red square number 3 that says VAUX if we're going to do SM bus access out of band. So if we support 4, do we have to have VAUX also, or is what's the linkage there? I don't quite understand that combination.
Yeah, the SM bus has an EEPROM for VPD data that typically is powered by the auxiliary voltage. Typically, that's a 3.3 voltage auxiliary. You can power that EEPROM from the 12 volt, but typically in the past, people read the EEPROM for VPD data before they supplied power to the drives. And that was the issue, is if, we tied it back all together. If you need that out of band, if you need SM bus, right, then it's relevant for you to have the need for the VPD EEPROM reading before power is enabled. Because
they're coupled. So the way to say that is, if we decide we should have SM bus, then that implies that we should then also include VAUX to support SM bus prior to 12 volt application.
Well, they're not intimately tied together. You don't. You don't need VAUX if you don't have SM bus. Okay, that's a true statement. But the second question is, do you want VPD access without supplying power on the other power rails?
Yeah, one direction is definitely connected with it. If you don't require SM bus, you don't require the VAUX. But if you have SM bus, it's still an option to power up the EEPROM from VAUX versus 12 volt. It's an option. It's not a must-have.
Yeah. Well, but that also then is a critical question relative to, are we going to go with I2C, I3C going forward, right? I mean, because if we're going to go query what are people doing in implementations today, we need to know, do they need SM bus in high density implementations, and if they do they then also need VAUX? Because I thought the whole part of the motivation for that was to be able to identify what the device is before you apply power to it.
Right.
For VAUX,
but you could do it. You could hold these devices and not, even though you applied power, you could still hold them, right? So you have the ability to do it in other ways, and some developers do it without the VOCs.
It's a very, I'll say it's a very simplistic method of doing attestation, right? Because you can say my system only supports these PCI devices, and you exclude every other. So let's just say I'm going to support Western Digital, but I'm not going to support Seagate or vice versa. So you could do a level, at that level, you could do it and say, I'm not even going to let this device link up because it's the wrong vendor. Yeah. So now that's a completely bad usage of attestation, but it is very simplistic that you could do that.
Well, you can do it the other ways too. So there are other ways not for the drive.
I think it's a great use as long as it's WD that you pick.
Nah.
Yeah.
Well, no. I mean, you know that you have a vendor that does misbehaving PCI things, so you want to exclude them. If you allow them to link up and then you detect, they may have already done the bad stuff.
Right, it probably that's generally be done through the commodity managers instead of
right. I said it was poor, but that could
right.
be.
Or you can do it with the keying.
Well, that's all fine, but I think relative to our task here today, question number 4 is linked to a question above that's flagged as not a highlighted question. So my only point is that if you're going to answer question 4, we need to answer question 4 and the one above 3, right? That's not flagged as a priority.
Yeah, I think if we rule SM bus as not necessary, then that
then it's
goes away. If we rule as SM bus as necessary, then we have to go back and revisit that VOCs.
So one thought. So Brad's example you brought up a second ago. This actually is an interesting concept of using the SM bus, right? So while it's not a great thing for attestation, it would allow you to prevent other devices from being plugged in. So let's say since we were talking about connector backwards compatibility, someone plugging a SAS drive into one of these systems, instead of even trying to turn it on and try to train, if you had kind of, hey, what's in here? This doesn't seem compliant. It's probably a bad use of that, but it's an interesting use case.
Mm-hmm.
Well, in that case, you wouldn't be able to talk to that SAS device through the SM bus.
Try training to it, but it's not going to work.
Yeah, it's not going to work.
Man, you won't be able to reach an EEPROM because it doesn't exist. So. Well, I think, what it boils down to is, again, we need to have the next stage is to have the designers of those systems guide us on whether they're going to use those features, even if we have I2C, SM bus, even if we had clock, ref clock, even if we had the VOCs, do they see enough pros to pay for the extra cost to connect to them, or would they see enough cons in adding complexity and they would not use those if we even add them in there? That's the kind of opinion that I'd like to get from the system builders in the OCP domain who have been building very cost-efficient solutions and were interested, and the reason they joined, I guess, is their interest in having an enhancement to processing capability and bandwidth, but without adding cost. If we came in and said NVMe HDD is going to add cost, I don't think adoption would be at the same level. We have to keep that in mind and ask the designers what would they do if we had those signals.
So Mohammed, what I can do is I'll have a conversation with our internal team, leverage some of our past experiences on previous systems. We'll talk about kind of our next gen that would adopt this. We'll try to weigh some of the pros and cons, and maybe at least from the Microsoft perspective, we can share some details and thoughts in the next presentation.
Can we get some feedback from at least one more commitment from a committed systems vendor? I don't know if WeWin is on the call or.
Any other system creators on the call that are willing to weigh in on this?
If you don't mind, Jason, let's send that in an email afterwards and ask we can get a response from any system vendor who's willing to help us in that decision. Just pretend that they're having to make that call today, and what would they do?
And from the Seagate side, since you have a systems team, can you also provide that from your perspective as well? So at least we'll have 3 data points.
Yeah,
we'll do. I'm hoping also WD would be willing to do the same.
Hey guys, Mohammed, from a switch perspective, I'll go back and check with some of our customers just to get a gauge of what they're doing in terms of clocking and burst and provide it to this group here. I can't give specific information, but I can certainly look and give a broad summary.
That'd be great.
Yeah. And
yeah, Mohammed, I will do that. Oh, sorry. Bill, was that you?
No.
Yeah.
I'll Dave, I was thinking Fred Knight and maybe David
Black.
David Black, yeah. Since they're familiar with both systems and NVMe pretty extensively.
They'd be good to ask. And I'll talk to our platform for WD. I'll definitely ping our platform team, see what they have on the I2C fan out issue, and I'll talk to some of the SSD designers about it first.
Okay, I'll reach out to David and Fred.
You want to ping? Okay.
I'll copy you as well.
Okay, cool.
Yeah.
Let's do that, and I'll reach out internally to our systems team and try to get that feedback as well.
And Jason, do we want this for the next call, or what's that?
Yeah, I think the next call would be the best thing if we can do that. So I can commit Microsoft will share our perspectives on that. I'm already talking to some of the team in parallel, so we will be ready. Hopefully others can provide some of their data points. I think this is key. I mean, realistically, what I'd like to see us do is in the next month or two, drive resolution on all these open items. I think we've closed out a lot of the other keys, and I'd like to be able to draft an OCP NVMe hard drive spec that basically, just a few pages covers here's the form factor, here's the connector compatibility, here are the signals we need, here are the power envelopes that we want to see. So a high-level OCP spec that we can then have kind of an agreement as a team that yes, this represents the ask, and that we can start getting that to the standards bodies to actually drive the detailed specs based on this.
Be great.
All right, so either David or Mohammed, do you want to send an email to the mailing list asking about the system providers? I will likely forget, so if one of you guys are willing to volunteer to send that email.
Sure. I think between David Allen and myself, and we'll get it done.
Yeah, just send it to the mailing list. Make sure that people are there, and if you have contacts and think that there are certain companies that are willing that maybe didn't speak up on this call, definitely reach out to them. And anyone on the call who's on the fence about it, you don't have to necessarily commit now, but if you have time to work with your teams and want to come back and share an overview next week, I think the more data points, the better. I can tell you just brief conversation on the side with my team. They're like, hey, SRIS makes things a lot easier, but doesn't have a lot of adoption, and they're certainly hesitant until they've seen use cases successful with it. So I think until people have run it, confirm that SRIS works, I expect that this will probably be a fairly universal view that, hey, this looks great on paper, but let's prove it out.
Okay, so Mohammed, I think I don't know if Jason, if you meant Dave, or the other Dave, but I think we should send a note to the storage project list that kind of encapsulates the 2 questions that we had, and I'd be happy to work with you, Mohammed, on drafting that.
Sounds
and
good.
then the other thing was Dave Allen said we'd ping our colleagues at NetApp and EMC, and then the rest of us will do the other things we said, talking to internal folks, and try and be ready in 2 weeks.
And Dave, I'll forward that email. Yeah. Okay.
Yeah.
And I noticed Ray also volunteered. He's going to give us a switch perspective.
Yes, correct. Mohammed, where are the notes going to be sent and posted for today's meeting?
Typically, we add them to the open specification notes document. Are you taking notes, Jason, today, or?
I have not, but I'm sorry, I have a finger injury. We have one. It's in the meeting invite. I'm pulling it up now. So everyone should see it. It may only be in one of the 2 monthly invites, but there should be a link.
Okay, okay. I mean, it'd be good, like I think someone is taking the action to articulate those two or three questions so that we're all on the same page.
We'll send. This is Dave. We'll send those We'll send those 2 questions out, and I think in general it would be a good thing if we started doing minutes more rigorously. But at least we'll get those 2 questions out to the reflector, and so then you'll have those.
Started.
Okay,
yep.
Thanks, Dave.
Yep.
Anybody else, like I think from Broadcom, from a switch, from Microchip, I think we have at least some feedback. Brad, anything else you want to add from your end? You want to anything differ? Anything different in the questions? Anything additional in the questions?
No.
Okay. All right. So I think we're out of time. Let's just
before we close,
I'll set up some time with you, David, and we'll draft the email.
Okay, great.
I hope everybody, before everyone drops. So if you go to the Open Compute, so Wiki Storage NVMe hard drive, this should work right here. So this was where we were consolidating. I think it's a little bit messy. We had it from some of our earlier calls, but you can see some of the history and meeting minutes in here. We should probably get better about utilizing this.
Yeah.
And then everything.
You always have the recordings though too, so.
Correct, and we are posting things on here, so they should be here. Say the last week, the recordings, but also the survey results are here. And we'll try to get better about doing this. The wiki is a bit of a mess. I apologize. At some point, Dave and myself need to start going through this and making it a little more optimized. All right. Thanks, everyone. We have a full agenda for the next occurrence. So we'll see you then.